Welcome to the DIY Honda Garage channel. The DTC P1AF0, which stands for Input Power A, Voltage Out of Range, indicates that the Powertrain Control Module, PCM, has detected an abnormal voltage level in the power supply circuit. This can occur if the voltage supply to the PCM falls below or exceeds a specified threshold. The PCM is a crucial component located in the engine compartment, responsible for controlling various engine functions and ensuring optimal performance. When the PCM registers a voltage that it deems abnormal, it triggers this diagnostic trouble code to alert technicians about potential issues in the electrical system. It's important to note that this DTC could also be triggered if a high-voltage battery, such as a 24-volt battery, is connected to the vehicle. Therefore, it's vital to check battery connections and ground cable integrity as initial troubleshooting steps. DTC P1AF0 indicates a failure in the voltage supply circuit that feeds the Powertrain Control Module, PCM. Components involved in this circuit include the PGM-FI Main Relay 1, PGM-FI Main Relay 2, and the PCM itself. The PCM is typically enveloped in the engine compartment, where it monitors engine performance efficiently. The role of the main relays is to ensure a consistent and reliable power supply to the PCM and other critical components during vehicle operation. When electrical issues arise, such as a drop or surge in voltage, the PCM identifies this as an anomaly, which leads to the storage of DTC P1AF0. Problems can often originate from corroded battery terminals or loose connections, particularly at the ground junctions within the engine compartment. Several potential causes can trigger DTC P1AF0 in the Honda CR-V. Firstly, corroded battery terminals can prevent a proper electrical connection, leading to voltage irregularities that the PCM detects. Secondly, loose ground connections in the engine compartment may also cause inconsistent power supply to the PCM. These ground connections are essential for stable operation as they complete electrical circuits throughout the vehicle. Additionally, there may be faults within the main relays, specifically in the PGM-FI Main Relay 1 and its corresponding circuits. Any defect in these relays can obstruct the flow of electricity to the PCM, leading to voltage readings that fall outside acceptable ranges. Hence, understanding these causes is vital for accurate troubleshooting. Diagnosing DTC P1AF0 in the Honda CR-V typically presents users with several noticeable symptoms. The most immediate indicator is the illumination of the check engine light on the dashboard, signaling a detected fault requiring attention. Additionally, drivers may experience reduced engine performance, likely due to the PCM's impaired ability to control engine functions correctly. This can manifest as sluggish acceleration or stalling, leading to frustration during operation. Starting issues may also arise, where the vehicle may fail to start or exhibit prolonged crank times. Recognizing these symptoms promptly can help in early diagnostic procedures and potential resolutions, minimizing further impact. The first step in troubleshooting DTC P1AF0 involves testing the PGM-FI Main Relay 1. This relay is crucial as it controls power supply to the PCM and other related components. Initially, ensure that the relay is functioning correctly by verifying its operation. Check for any abnormal voltage readings at the PCM supply lines. If the relay is found to be malfunctioning, or if voltages are out of specification during the test, then replacing the relay is necessary. Closely inspect the connections leading to and from the relay to confirm that they are secure and free from corrosion. This systematic approach allows for targeted diagnosis before moving on to more complex inspections. The next step involves inspecting the external circuit connected to the PGM-FI main relay 1. It is essential to examine the plus B IGP circuit, which serves as a primary power input to the relay. Begin by confirming the circuit's integrity by checking for any open wires or shorts that could disrupt the power supply. A thorough inspection should focus on potential bare connections or issues along the wire harness that might impede electrical flow. If any faults are identified during this assessment, they must be rectified to ensure continuous power to the PCM. This step is critical because any interruptions can lead to abnormal operational status and further complications with the vehicle's performance. In the third troubleshooting step, the focus shifts to performing a direct inspection of the PCM itself. Before approaching this step, it is paramount that the PGM-FI main relay 1 remains disconnected to prevent interference during assessment. Start by verifying that all connectors related to the PCM exhibit solid connectivity. Ensure there are no corrosion, bent pins, or loose attachments that could affect performance. If tests indicate that all external connections are in good condition, proceed with evaluating the actual PCM for internal faults. Often, if the PCM has sustained damage or malfunctioning circuits, it is the primary cause of the DTC P1AF0, necessitating replacement or repair. Upon completing the necessary repairs and inspections, it is crucial to perform a final repair verification. Begin by clearing the stored DTCs in the PCM, including P1AF0. Afterward, conduct a system retest to confirm that the DTC does not reappear. During this retest, monitor normal operational parameters to ensure that the vehicle runs without issues and that all systems function properly. It is beneficial to perform a driving cycle as well to ensure that the vehicle responds accurately during real-time driving conditions. Verification concludes the troubleshooting process, providing confidence that the issue has been resolved effectively. To prevent recurrence of DTC P1AF0 in the future, routine preventive maintenance is essential. Regularly check battery terminals for corrosion, which can severely affect power delivery to the PCM. Ensure that all ground connections are secure and free from rust or deterioration, as these connections are fundamental for the vehicle's electrical system. Additionally, periodically monitor the functions of the main relays to confirm they are performing as intended, without intermittent failure. Implementing a structured maintenance routine can preempt many electrical inconsistencies that could lead to future diagnostic trouble codes, ultimately enhancing the reliability and longevity of the vehicle. In conclusion, DTC P1AF0 serves as a significant indicator of voltage irregularities in the Honda CR-V's electrical system. This diagnostic trouble code can often be triggered by factors such as corroded battery terminals or loose ground connections, highlighting the importance of thorough inspections during troubleshooting. By following the outlined diagnostic steps, technicians can accurately identify the root causes and implement effective repairs. Moreover, adhering to a rigorous preventive maintenance schedule will help to mitigate risks associated with electrical failures, ensuring that the vehicle operates efficiently and reliably in the long run. Through understanding DTC P1AF0 and its implications, vehicle owners and technicians alike can maintain peak performance. Please like and subscribe to the channel. See you next time.